Okay, if you remember, in the last session, uh, we had drawn some graphs. So it was a histogram using the Seaborn library. And we had created a rig plot, a scattered plot, using the lot area and the sale price, okay, from the original housing data set. Then we saw that there was some outliers. These were my outliers. Outliers are values which are either too high or too low, okay, or very big, you can say very big or very small. And to check the outliers, we also displayed the value of quantiles. So we started with 50% and we saw what is the value at 50%. Then we saw at 95 and at 99 as well. And we realized that the value for, between 95 and 99 are too high, okay, on the higher side. So what we did was, first of all, we also checked the correlation between the two variables, that is your lot area and the sale price. And we found that the value is coming too low, that is 0.26. Okay, it hardly shows any correlation between the two variables. And then we removed this, you can say, outliers. Now to remove the outliers, we had created a new data subset, of a data frame called housing underscore sub. And we had given a condition. So we took only the values up to quantile 0.95. Okay. So less than quantile 0.95 were taken and stored in housing sub. And then when we saw the description of that particular data frame, we got 95% value for, let us say, the lot area was coming to 7411, 50% to 9247, and the maximum was coming to 17400, which was a bit better compared to the previous one. I think very much better than the previous one. And then we plotted the scattered chart again, the graph using the rig plot function, where on the x-axis we plotted the lot area and on the y-axis the sale price. And then we saw that there was some better distribution of your dots. You can see this. There was some better distribution, and we also understood there is a relationship between the two variables, that is your lot area and the sell price, even though it was not a very high correlation, because the value was not above 0.7, or it was between you can say it was 0.43, which we calculated. Okay, now if I want to check the skewness of all my variables all together in the data set, okay, I can make use of the function called skew. Okay, so because we have this housing data set, so first of all, let me see this function on this data set, housing dot skew, and I have to put the round brackets. Now here you can see how skewed your data is. Wherever you have like negative values, that means there is hardly any relationship between the data is very skewed, you can say. Even the higher values, okay, these are the values which, even the values which is greater than, not very close to 1, for example the lot area, you can see we were focusing on lot area, it is 12. Okay, so it is right skewed. Okay, the negative values indicates it is left skewed, and all the values which are very close to 0, okay, indicate that they are, there is some relationship. So if you want to see, there might be some variables where the relationship is very good. So all the values which is very close to 0, for example this one, years old, okay, it's a very good relationship if or skewness, it's properly distributed data. So if I want to find out relationship between years sold and the price, I might be able to get some better indication. You can also check it with the new housing sub data frame which we created. So, and we'll focus on the lot area, because if you look at this now look at the value of the lot area. It has become minus 0.1317, and previously it was on the positive side, which was 12. Okay, so it was more on the right hand side, like right skewed, as I said. And now because of just removing or taking the data up to 0.95 quantile, I got a value which is now a bit of very close to, you can say, 0, but on the left hand side, skewed on the left hand side, but not very much. So this is very much a balanced data, you can say. Okay, so please remember, whenever you are trying to find out some relationship between two different variables, especially when we are going to do linear regression, linear relationship, or correlationship equations, and finding out different charts, I need to check for this outliers, because outliers are the spoilers. Okay, so if whenever you get a data set, the first thing you need to is to go through the data, analyze the data, understand the data. Okay, if required, there's you need to filter it. Okay, remove records which are not required. All this has to be done. If you remember, we did cleansing where we had removed NA values. Okay, all this stuff is required until and unless your data is of a quality data, and it is very much relevant. Only then you'll be able to go ahead and do some predictions. Okay, so to go ahead, after doing this bivariate analysis, especially using your rig plot, let us see one more. Now, let us see if I have to analyze the relationship between the sale price and all the square feet related columns. Now, if I have to see the columns which is having square feet, all the variables which are ending with SF. Now, this one, SF, here we have SF again. So these are all related to your square feet. Okay, so like first floor, second floor, balcony, might be a basement, all this will be in some square feet area. Now depending on the square feet, your sale price might change. Okay, but here the condition is, okay, I need to you can say find out the relationship between a sell price and all of the square feet related columns. Okay, now to do that, first of all, I need to figure out which are the columns which are having this square feet in the column name itself, or SF in the column name. So to get that, what I'll be doing is I'll create a list of all this SF columns. Okay, so let me create one, you can say, list by the name SF underscore calls. Now this will be equal to, again, I'll be making use of a for loop in, so it will be a comprehensive for loop. So I'll get all the column names, column name for column underscore name in. Now I'll be using the new data set, or if you want, you can also make use of the old one. Let us make use of not the housing underscore sub, but the housing data set or data frame. So in, I'll be using housing dot, and how you refer to the columns, dot columns. Okay, now in this, I need to have a condition. So I'll just give the space. If SF, now SF, it is in capital, you can see this, SF is all capital. So SF in column name, in column name. Okay, and just complete your square bracket. That's it. Let's run this and try to find out how many variables I have. So to find out how many variables I have, what I can do is I can write len into bracket SF underscore calls. Okay, so total, you can see I have now 9 variables. Let us display those variables. SF underscore calls. Okay, these are my 9 variables, which is having square feet values in it. And now I want to find, I want to plot a graph for this relationship, because we have multiple graphs here. Now, instead of using your rig plot or any other type of plot or for histogram, whatever, instead of that, I'll be using subplots. Now, I'll be creating subplots. Okay. Now, to do that, there are two different ways of doing it. One is just using the function called pair plot. Okay, where I can create pair plot for the whole, you can say, the data frame. Okay, but that is not what I want. I want it only for this 9 columns. Okay, so if I have to refer to this 9 columns, I need to first of all create a subplot. Okay, and I also have to use a loop to, so that I can plot the graphs, the related graphs in a particular, you can say, if I am having a grid where there are different subplots in that particular grid. So I'll be referring to one plot at a time using the index positions and plotting the graph. Now I'll quickly write the code. Let us say I have to first of all create a subplot with the size and the figure size and the axes. So I can write FIG for figure, special, and let us say axis equal to. Now here I'll be using a PLT. PLT is, I think we had imported this on top, is my alias for the pie plot, this one, under matplotlib. Okay, PLT is there. So I'll be using the matplotlib py plot. Okay, so the variable which I'll be using here will be PLT, which is the alias for my, you can say, function. Now we have a function called subplot. It is subplots into round bracket how many rows you want. Now because I have 9 variables, I'll keep 3 as my rows, and I'll keep n columns also as 3, so that I'll get total 9 graphs. And you can mention the figure size or the overall plot size. The plot I can give as FIG SIZE size. Now it will equal to the dimension. I can give 10 by 10. Okay, you can give any. If it is very small, you can decide and go ahead with a bigger size. Now coming to how do I plot it, I'll be using a for loop here. It won't be a comprehensive one. I'll be using the simple for loop for I in range. Now because the first plot, if I want to plot it in the first plot, in the first subplot, it will be 0, 0, right? So I need to create this. A range will start from, let us say, 0, and it will go up to the total number of, you can say, fields which we have, or columns we have, 9, which is 9. So I can make use of len into bracket sf underscore calls. Okay, this will help me go up to 9. Okay. Now under this for loop, I need to first of all get the row number and the column number from the value of I. So what I can do is, I can, if I divide the value of I by 3, okay, and especially the integer division, and also get the column value. So if I do this, the rows equal to I, the integer division divided by 3, and for columns, say calls equal to I modulus 3. Okay. Now I won't do anything here. I'll just try to display this value, so that print rows, comma, columns. Okay, I'll just run this one. Here you can see now, because I'm able to get this plots. So this is my subplot. You can see this. These are empty right now because I have not plotted anything. And these are my values for rows and columns. So when I refer to 0, 0, I'll be able to plot it here. 0, 1, I'll plot it in the second column, first row, and 0, 2, I'll be able to plot it here. Clear? One more thing is, let us remove this one. I think the size is looking too small, so I can go for 20, 20. This is a better size. Okay. Now, rows and columns I have already created. Now I need to give it to the axis. So AX equal to ESX and square bracket. I'll mention the rows and the columns. This I'll be using while plotting my rig plot. Okay. After this, I need to plot it. So I can give plot equal to SNS. SNS is your seaborn alias dot rig plot. Now, rig plot takes the X variable and the Y variable, okay, and the you can say data set, the data frame from where I want. I'll be also passing one additional information here, the axis, that is the rows and the column. So let us pass the first parameter, X variable. So on the X axis, I want to display the column SF underscore calls square bracket I. The first will come here, comma. On the y-axis, I directly have the sale price. So I can give you in double quotes, I can give sale price. Okay. The third parameter is the data which I want to pass. Now I'll be using housing here and not housing sum. And the last parameter is important where I want to plot it. So the axis, kx equal to kx. So it will go for this row and column. Okay. Now when I run this one now, it will start plotting something. Yeah, here we go. So you can see this now. There are totally 9 plots which have been created. And for this, I have made use of the rig plot. The first plot is coming based on the surface area. And you can see this is a better relationship here. You can see the line going up. Whereas in the second one, basement, I think basement, FIN, SF, it is a very flat line there. So there's no relationship, you can say there's hardly any correlationship between the basement FIN square feet, the area, and the sale price. And there's a very high, you can say, correlationship between this basement FN SF1. Okay, might be floor 1 or something. So there's a very big relationship here, a very good relationship, high relationship, you can say, correlationship. Then again, the total basement, there's again a good relationship here. Again, this is also showing some relationship. Okay, this one is hardly giving any relationship between the two variables of low quality. I think this is low quality finishing or something as well. Okay, you can refer to the description of this data set if you want. Actually, I was supposed to show you that description. So if you can go to the website and download the description file for your housing price data set. And the website which I told you was Kaggle, Kaggle. Okay. And I'll request you all to just register on that website so that usually what happens, there are lots of data sets which are provided. And there are lots of competitions which happen on that particular website, especially related to your data analysis, or you can call it as data science. So lots of machine learning, you can say, projects are displayed or given to you for practice purpose. And you can also refer to the projects which are uploaded by others as well. Okay, so that will give you an idea how, others are also carrying out their projects and so on. So I'll request you all to just go through that website and register yourself. Now there is again some database which is available, which is Iris database, which is, I think, can be downloaded, or it is also by default will come along with Anaconda when you load it. So if you want, you can just check it out in that particular, you can say, Anaconda dataset file folder. whether you have a file called iris, iris. If it is not there, you can download that, and you can do lots of plottings, visualizations based on that particular data set. Now let us go further, and let us check if there's a relationship between some other variable. Let us see if we want to check if the price of the house impacted by the exterior covering of the house. If I want to do that, how I'll do it. So if I want to do that, and let us use the same data set, the first thing what I'll do is I'll try to find out the value count. So the variable, let me check the variable name. The variable name is exterior first. Okay, so it will ext exterior, and there's a 1 year first. Okay, dot value counts. Okay, so these are my different exteriors which are there. So Vinal, if you remember, we had plotted a graph, the bar graph, with this particular, you can say, column. So this is vinyl SD, then HD board, and so on, metal SD, and so on. This is my exterior. I think might be the way the exterior has been colored, or what has been used for the exterior in the house. Okay, now if you look at the first, you can say 1, 2, 3, 4, even 5. These are mainly used, whereas the others are having very less values. Now suppose let me first of all plot a graph for this. So I'll make use of again FIG axis equal to PLT plot dot subplot into bracket. Let me create a figure of say figure size 10 by 10. This will be a smaller one like the last one, and I'll create a plot as I will directly create it. This time I'll be creating a box plot. Okay, so it will give me the values of, you can say, the median, also the quantiles. The first quantile, second quantile, and the third quantile will be used. The box plot is also known as your box whisker plot. If you Google it out, you'll find some different names used for box plots. Your whiskers are like, that you can see that head and the tail. There are two lines which are coming out of a box. Okay, and those indicates the quantile values, the higher end and the lower end values. And any point or any value which is lying above, especially the outliers, which are lying beyond the 2 points, are known as your outliers. Those are your extreme points, you can say, very small or very big values. Okay, so let us use this box plot. If x equal to, this will be my variable exterior first. Okay, and on the y-axis, give a comma, y equal to the sale price. Okay, and here again I'll be using the housing data. So data equal to housing, and the axis ax equal to, I've just created axes axs. Okay, there's some error here. Let me check the error first. Okay, the number of columns, I have created only one subplot. There's no issues here. Comma, size is okay, figure is okay. Okay, I can give you a plot equal to Oh, there's an error here. PLT subplot. Okay, this is not plot, it is plots. Fine, and I don't want this. Let me run now. Okay, fine. Now these are your box plots, and these are your whiskers. As I told you, these lines, these are your whiskers. Now this points, the line which is in this box here, this line is your median. Okay, this indicates the median, right? And these are your quantiles. You can see this is my quantile 1, quantile 2, and quantile 3. Anything which is beyond this are plotted as points. Now these are your, you can say, what you call it as outliers. Okay, so these are the points which are will create some problem when we do actually correlationship. One more thing, if you look at the name of the, you can say, the values, they are not properly plotted. So if you remember last time, we had made use of a function to change the rotation. So let me do that again. I'll give better names. So here I can give plot equal to, go to the end. Okay, and now we will set the tick labels. So plot dot set underscore x, but I'm getting x, tick labels into bracket plot. This time I'll be using get underscore x, labels. I hope it is labels and not label. And then I need to rotate this. So last time I rotated, I think, by 40 degrees. So rotation, we are going to keep it as 40 degrees. Okay, this, I think this will give me a better solution. Let us run this now. Okay, now, okay, I did not display the plot. Here we go. Let me see the names. Yeah, now it is better. Okay, now if you look at this plot, it is not that informative, because there are some categories. There are some categories which are not so much you can say use. If you look at the values which we had got, these values, if you look at the first three, it was good. It was 515, then 222, 220, 206. The rest of them can be clubbed together. So if I want to plot the first three or first four, let us say first four, and club the rest of them, and then plot a combined graph for this rest of the, you can say, exterior. So what I can do is I can create a new, or you can say, a column, and club this, except for the first three or first four, I'll be able to club the rest of them together as others, and I can plot a box plot for that. Now, if I have to create a new column, let us say the name of the column, let us say it is, say, exterior new. Okay, with only the first top, let us use only the first top three columns or three values. Okay, and convert all the others into a new heading called others. Okay, and then plot the relationship between the sell price and this new particular column, how you'll go about doing it. So first of all, what I'll do is I'll get the first top three, you can say, values. So to get it, I'll use, say, top. Let me use top. I need to click here. Say top three exteriors, and use exterior. Okay, equal to, say it is in the housing data set, data frame, and the name of the field is exterior first. Okay, and from this I want to use dot value counts. I want to get the first few heads. So it will be dot head, and I want n equal to, say, let us say 3. Okay, I want the first 3 records. If there's any error, no error. Okay. Now this I'll convert whatever names I'm getting. I'll convert this into a list. So say top 3. Let me use top 3 exterior equal to, and the function which we use is the list function, into bracket top underscore 3 underscore exterior. This will convert and create a list, but I do not want this top 3 counts. I want the index position of this. So I can use dot index. Okay, and execute this. Let us see what we have in top 3 exterior. Okay, so here you can see this. These are the 3 names which we have. So it is referring to that index, and from that I'm getting the values. Now, if you want, you can also display this one, top underscore 3, and you can see these values are also there. Now I don't want these values, I want only the names, and that's the reason I used dot index. Now, why this is the index? Yeah, we do not have this 0, 1, 2, 3, right? 0, 1, 2 would have been the index, but it is not there. So when we display this after using the function value counts dot head equal to n equal to 3, actually the name of the exteriors are acting like an index, and that's the reason we have used dot index to get the names. Okay, so the numerical value which is by default, 0, 1, 2, 3, those are not present in this case. Clear? You will say why we have used index and you are not getting 0, 1, 2, 3. The reason is because here the name of the exteriors are considered as the index. Now let us go ahead and let us create the other field, the new field. Okay, and this 3 field will be added as 3 different. So what I'll do is I'll create a new column in the housing data frame. So let's go to housing. The name of my new field on new column, let us say exterior new. Okay, so this is my name for the field. I'll use underscore here, so for better understanding. Now I have to make use of numpy np ls dot the condition, because I have, based on the condition, I'll be moving the records. Now in this, the condition is housing, HOUS, housing exterior first, exterior first. Now whether it is in, so is in is the function, your top underscore 3 exterior. Okay, so if it is in this, what we do, we get the same record and put it in my column. Okay, no need of any changes. So housing square bracket exterior, there's no change here first. Okay, the main change will come if the condition is false. It is not, it is something else, it is not among the top 3. I want to put it in the other, you can say, category. That other category is others. Okay, so I'll give a comma here and put it in others. Okay, so what will happen in the new column, apart from this first 3, that is your vinyl, HD board, and metal, this will be stored. Whereas for others, you can say other exteriors, it will be stored as others now in my new column. Okay, so if you want, we can just run this and also display it. I'll display housing. Okay, and let us say add and first 10. Okay, so here's my first 10 records, and can just go. I hope the exterior name. Yeah, you can see this now. Others have been added here. Right? Might be all of these are others only. Clear? Now let us use this data now and use the function called value count to check what is happening. So instead of this, I will use housing in the square bracket exterior new. Okay, and I'll make use of the value count function. So this will give me the values for the exterior count. What has happened? Okay, so I got only others here. There's some problem. So everything got converted into others. Let us check this where condition. Housing exterior first. Mm, okay. Now this is a problem here. I should have made use of exterior 3 like this. So let us uh, redo this whole thing. Run this. Now it is okay. So we have a new column now with vinyl. Okay, SD as 515. Then others are now 503. HD board was 222, and I got another one as 220. Now using this, I can uh, just plot the box plot. Okay, so I'll make a change to my plot, which I'll just copy it from top where we had got the box plot. There it is, this one. So let me copy this one. Your first statement has already been created. So I already have a subplot. Still, let me copy it. We'll copy this down. I could have run that as well. Okay. So what we have done, we have created now instead of using this exterior first, I will go ahead and change this to the what was the name of exterior new. Okay, and I'll keep on the y-axis sale price. Database is fine with me. It's housing, and fine. I can plot this. Okay, let us see whether it's yeah. Okay, so now what has happened? I have you got this others now. Your others are having the information of the other exteriors, and this my vinyl, and this chart looks much better compared to the one which we had before, this one, because there were many can see exteriors which were available, and where the values these values, especially the ones which was like 50, 26, 25, this hardly made any sense, gave me any input. So we converted this into others. Okay, I could have included the first four because this 206 and then this one. That would have been better option, I think. So instead of top three, if you want to change this to top four and then convert the remaining into the category others, you could have changed it. So instead of getting the top, you can say three from using this n equal to 3, instead of that, you can use n equal to 4 and then rewrite this whole code. Okay. I hope this is clear how to get a box plot and how to combine multiple columns records in a single you can say record. Okay. Now the next question, let us say we want to find a relationship between the house exterior and price change depending on how old this the house is. So for this question, we need to simply categorize our data into two, you can say categories,
Yes, sir.
old house and new house. Yes,
Excuse
any
me, sir.
question?
So, but what does this chart indicate then?
This chart will help me get the mean and the actual distribution. Now, this will tell me, this will tell me that more of my data is clustered in between this range. So sale price for, especially for this one. Okay, you can also check the median. Okay, the median for others, the median for is HD board and so on. Plus, you will also get to know what are my outliers. Outliers, all the points, especially these points. You can see these points here. So based on this, see, this chart is just helping me to understand the data, what the data I have in my CSV file or in the data frame. I'm not performing any machine learning here. Now I cannot feed this data as it is to my machine learning algorithm. I need to first of all understand the data. And this is what we are trying to do right now. Using different graphs, we are trying to understand how the data is and what different types of data I can collect. Now, later on, if suppose you do not require the other exteriors, you can say, while doing the analysis. So why do we need to pass all these variables or all these values? Okay, it doesn't make sense. Okay, passing all this and doing the analysis. So how do I, read the data in a different way? So we are trying to understand the data, nothing else. Okay. If you want to learn more on different types of charts, you can just refer to the box plot and try to understand what it represents. Okay. And whatever I have understood, whatever I've learned, the box plot actually gives you three basic information. One about the outliers, the median, and the area under which my this as I told you this my quantiles. Okay, so this is my 95. You can say if I refer not 95, sorry, this will be my first quantile. Okay, so majority of my data you can say lying between this end to this end. Not majority, it is 25%. So this 25%. This whole from year to year is 50%. Okay, and this is your next 25%. Again, in this value, the values which are very high, it's going beyond. So you need to find out what this line indicates here. Okay, this is I think a third quantile. This is your third quantile. Okay, so I'm not
So,
very
and
much
what does
clear
the
about this.
outliers indicate?
Outliers indicate that the values are either too high or too low. Okay. Now, when we talk about the salary, I give an example of salary. If suppose I want to find out the average salary of a particular, you can say company or employees, or let us say we all people, let us say there are 10 people who are working, who's attending this session, or in the staff room. If I include all the employees of our teaching faculty and try to find out the mean value, okay. So what happens is I'll get some figure which will indicate that the average salary of the employees of Naval Vadia, especially in the teaching fraternity, is about some XYZ. Okay. But suddenly, if suppose we employ a person or a other person comes into the staff room, which is having a very high salary. Let us say the CEO of this modern education society is included, and the average salary for all the employees here is coming around say 60,000. As soon as I include a person who's having say 5 to 6 lakhs of some salary, okay, what will happen? My average will increase. Okay, so any value which is too high or too low are your outliers. Okay, so in this case, you can see my outliers, like in the example of your lot area, we had removed all the values above 0.95 quantile. Okay, and then we use that values to plot the graph. We have very less time. I think 1 minute is left, but I think I am very much clear on this point.
Yes,
We will
sir.
stop here. I think we will stop here. You go through this box plot again and try to understand what it indicates. Clear? So
Yes,
we'll
sir.
stop here. Next time when we come, we'll take some more points here. And we'll take a case also. Okay.
Yes,
Thank
sir.
you, everyone. Thanks. Thanks a lot.